In this video, I want to give you more practice on finding the domain of the quotient of two functions. So here we have f of x equals x minus 2 over x plus 3, and g of x equals x over x plus 3. And we want to find f over g and then give its domain. So f over g means that we're going to take our f function, x minus 2 over x plus 3, and we're going to divide by the g function, which is x over x plus 3. Now we know from working with quotients that we can flip the second fraction and change to multiplication whenever you're dividing by a fraction. So this would become x minus 2 over x plus 3 times x plus 3 over x. Okay, and now the x plus 3 cancels because it's in the denominator and in the numerator. So I'll actually just get x minus 2 over x. So that's f over g. And now we have to figure out the domain. So let's start thinking about the restrictions on the domain. We know that g of x cannot equal 0 when finding g over x. I'm sorry, when finding f over g. So when finding f over g. And so I'm going to have g of x equals 0 when x equals 0. So x over x plus 3 equals 0 when x equals 0. So that's going to be one of my restrictions. In the domain, x cannot equal 0. And then the other thing is that both functions have to be defined, and they're not defined when you divide by 0. So x could not be 3, negative 3 in this case. So it's undefined when the denominator x plus 3 equals 0. So that would tell us that x cannot equal negative 3. So we have x cannot equal 0 and x cannot equal negative 3. So we would put that in. We would go ahead and put in our f over g as x minus 2 over x. And then our domain would have to be all real numbers except for negative 3 and 0. So I'm going to do parentheses, negative infinity to negative 3. Go ahead and do the union. And then we'll do parentheses, negative 3 to 0. And then the union. And then 0 to infinity. So remember, your restrictions are g of x cannot equal 0, and the denominator of each individual part cannot equal 0. Let's try one more. Okay, so we have f of x equals x over x minus 8, and g of x equals x plus 4 over x minus 8. So let's go ahead and find our f over g. That's what they're asking for. So we're going to have f over g equals x over x minus 8 divided by x plus 4 over x minus 8. So we flip the second fraction, so we get x over x minus 8 times x minus 8 over x plus 4. X minus 8 cancels, and so we just get x over x plus 4. Now the restrictions are that we cannot divide by 0, and also your original g of x. So g of x cannot equal 0. Both f of x and g of x have to be defined, and the denominator of your result cannot be 0. So that will actually be covered with g of x not equal to 0. So we have x plus 4 over x minus 8 equals 0 when the numerator x plus 4 equals 0. So that would tell us that x cannot equal to -4. So that's one restriction. And then the other is that our functions are undefined when the denominator is 0. So when x minus 8 is equal to 0. So that would tell us that x cannot equal 8. So for our domain, we would have -infinity to -4. And -4 to 8. And 8 to infinity. And up here, I would go ahead and put in my x over x plus 4. Let me see if I can find one more that's slightly different. So now I have two functions and they have different denominators. So let me go ahead and do this one as well. Okay, so I want to find g over f. So notice here it's actually a little different. Before we were finding f over g, but here we want g over f. So g is x over x minus 8. I'm going to divide by the f function, so divide by 6 over x plus 9. So I have x over x minus 8 times x plus 9 over 6. And nothing cancels. So in this case, I'm going to have x times x plus 9 over 6 times x minus 8. And that will be my final result for g over f. So the restrictions on the domain are that the denominator, f of x, because I'm doing g over f of x cannot equal 0, but 6 over x plus 9 is never 0. So there's actually no restriction from that part, never equals 0. The other restriction is that both functions have to be defined. So since both functions have to be defined, that means that x plus 9 cannot be 0, and that x minus 8 cannot be 0. And that's because of the denominators. You can't divide by 0, so neither denominator can equal 0. So I'm going to have the restriction of x cannot equal -9 and x cannot equal +8. Those will be my restrictions. So I'll go ahead and put my function in first. X times x plus 9 divided by 6 times x minus 8. And my domain will be, let's see, wrong thing. My domain will be parentheses, -infinity to -9, union -9 to 8, with parentheses to exclude the endpoints. And then 8 to infinity. All right, so remember your restrictions are both of your original functions have to be defined. So exclude any values that don't make those original two correct. And then whatever function you are dividing by, in this case f, cannot equal 0. But in this case, f of x never equals 0, and so that did not provide a restriction. All right, so I hope this helped with the domain part. That's one of the harder parts of this section, is figuring out your domain when you have the quotient of two functions.